So in this video, I'm going to go through some of our work for section 9.7, which is law of sines and cosines. In this video, though, I'm just going to cover area and the law of sines. I'll do the law of cosines separately because we are not quizzing over that topic. So the first thing we're looking at is area. And traditionally, we find the area of a triangle by using this equation. Area is equal to 1/2 base times height. And sometimes it can be challenging to find the height of a triangle. For example, in this one, remember height is that length from the base straight up to the top. So that would be our height. And that can be challenging to find. We did go over how to find these equations, but at this point I'm just going to go over how to use these to find area. So there are 3 different equations. So we need to first pick the one that's going to be most appropriate. Remember, when we look at our triangle, we're looking at this model to determine sides and angles. So, for example, I've got angle A here, so that means the side across from it is side A. This 19 is going to be side C, and the 17 is side B. Kind of sneak that in there. So, when I decide which equation I want to use for area, I need to look at what I've got. And right now, I have angle A, side C, and side B. And so if I look here, I want to choose the one that has those 3 things in it. Side B and side C, which are the lowercase letters, and angle A, which is the uppercase letters. So this is the one that's going to match. And so what I would do is I generally start by just bringing this full equation down. 1/2 BC sine of A. And it's important to remember that this is just a string of multiplication. This is 1/2 times B times C times the sine of A. So once we get everything just plugged into this equation, it's just going to be doing some multiplication on our calculator to get our final answer. So let's start substituting in. So 1/2 is just a number, that's going to stay there. B, we said, is 17. C is 19. And then the sine of A is 135. So at this point, just punch this right into your calculator, just like it is. The one thing I would recommend is instead of 1/2, I would use 0.5 because that is 1/2, and sometimes we can make errors with fractions on our calculator. So to avoid that risk of error, I would just do it like this. So you should get that the area is equal to 114. I've got 1977. I'm going to round to 114.2. So I definitely recommend punching that into your calculator, making sure that you can get that number. Make sure that you're putting that into the calculator correctly. So moving on, law of sines. The law of sines allows us to compare angles and sides. And so we want to set up these pairs of ratios. Again, it's going to determine what we have in our triangle, is going to determine which equation I want to use. I'm not going to use all 3 of these together. We're not going to create this equation with 2 equal signs, but we'll use any 2, right? So I might compare A's and B's, right? Meaning the angle A and side A, and I might compare those to angle B and side B. Or I could compare B and C and just do that equation that's left right there. Or I could set my A's equal to my C's. Okay. Any of these work. And we can also flip that if it makes it easier, right? Generally speaking, we want our unknown variable to be on the top of our fraction. So I'll talk more about this as we go through specific examples, but we have a lot of options here with how we can use this. So let's look at an example. So number 2, law of sines. And in this equation, I'm not going to go through the process of solving the entire triangle. Let's just look at finding angle B. So if I look over here, again, we always want to look at what we've got. Okay, so I've got angle A. And remember, across from that, this is going to be side A. So side A is 20. I've got side B, 11, because that's across from angle B. And I'm going to try to find this angle B. So if I think about law of sines, remember it allows me to compare things, and I always think of it as comparing like A's to B's or B's to C's, meaning I want to have both of one of these things. I do have, in my example down there, I have angle A and side A. And so if I compare that to B's, I have side B and I want angle B. So I don't have any C's. I'm not even worried about C's right now. I'm just going to compare the A's and the B's. And so knowing that, I can do one of two things. I can either set it up like this. Sine of A over A equals sine of B over B, right? That's this left way. Or I can do A over sine of A equals B over sine of B. Right? So I can do either of these two things. And I want to choose the one that is going to leave my missing part on the top of a fraction. That's going to make solving it easier. It's going to save me steps. If you choose the wrong one, you could still work it out. It's just going to be a little bit more work. So this is one of those points where I would pause, kind of take a look, see if you can figure out which one of these you would want to use, and then unpause. So if we go back to what we're trying to find, we're trying to find angle B. This on the left here, this has angle B, because that big B is the angle. On the top of the fraction, that's the one that we would want to use. Okay, so I'm just going to get rid of this. And this is the equation we're going to use, and we're going to start substituting in the things that we know, and then we're going to solve for what we don't. So I'm going to make it a little smaller so I've got a little more room. Okay, so sine of A. I know angle A is 115. So the sine of 115 over side A, which is 20, equals the sine of angle B over side B, which is 11. Again, this might be another good pausing point. Stop, take a look, make sure that you understand how we set this up and why we chose this way before we go into solving. So our goal is to eventually get B, just angle B. We're going to start by getting the sine of B. So we want to get that all by itself. And in order to do that, we're going to want to multiply both sides by 11 times 11. And I'm just writing it as 11 over 1 because it's easier to see that way when we do the fractions and we multiply. So on the right, the reason we did this is because now I'll have 11 on the top of my fraction and 11 on the bottom. I'll be left with just the sine of B. And on the left, we end up with 11 times the sine of 115 over 20. And this is all equal to the sine of B. Remember, I don't need to put a multiplication sign there. It's implied, right? This means 11 times the sine of 115 divided by 20. Again, this is another one of those things that we just punch into our calculator now. So 11 times the sine of 20. I'm sorry, not 20. I'm getting a little mixed up here. 11 times the sine of 115. Then we divide that by 20. And you should get 0.498. So 0.498 is equal to the sine of B. But we don't want the sine of B. We want to find angle B. And this is idea that we looked at earlier when we're trying to find missing angles. So what this is telling me, the sine of some angle B is equal to this ratio. And if I know the ratio and I want the angle, this is just inverse trigonometry. So I would punch into my calculator the inverse sine of 0.498, and that will give me the measure of angle B. So let me just punch that in. Inverse sine of 0.498, and you should get 29.9 if I'm rounding. So B, the measure of angle B, is equal to 29.8 degrees. All right, moving on. We've got a little bit of a word problem here. So the distance between consecutive bases on a baseball field is 90 feet. A baseball player catches a ball at point A and wants to throw directly to third base. How far must the player throw the ball? So I've got this triangle. Here's my bases over here, second base, third base. We catch the ball at A, want to throw the ball to third base, hopefully a little straighter than that. And we're wondering, how far is that distance that we're throwing? So before we even start to figure that out, there's a few more things that we can fill into this diagram based on other things that we know. So this might be a time to kind of pause and think about those couple of things. One thing that the problem tells me is that this distance between bases is 90. And since this is across from angle A, I'm actually just going to label this side A. Another thing that we can figure out is this missing angle A. Right, we know that the internal angles of a triangle have to add up to 180 degrees. So if we take 180 minus 53 minus 62, we get 65. So this angle A is 65 degrees. And what we're looking for is this side over here. We're looking for this length. We can label it anything we want because we don't have other labels. Meaning I have angle A and side A. I don't have B and C labeled. So let's just label it whatever we want. Okay, so I'll call this angle C and I'll call this side C. This would be then angle B and side B. We're always working with this ABC model. Again, where capital letters are angles and lowercase letters are sides. So if I'm looking for this side C, we want to compare this. We want to compare these C's. So I'm looking for side C. I know angle C. I want to compare that to something else that I know. And if we look over here, again, we know angle A and we know side A. So again, great time to pause and think about how we might set this up. Okay, go back and look at our law of sines. Okay, think about whether I want it to look like this with the angle on top or with the side on top. And then think about which ones am I comparing. See if you can set up that equation. All right. So we are comparing A's and C's, right? I've got angle A and side A, I know. And I know angle C and I'm looking for side C. So that's what I want to compare. I want to compare A's and C's. And again, I've got options. So I'm going to kind of quickly, I could either do sine of A over A equals sine of C over C, or A over sine of A equals C over sine of C. And again, I want to choose the one where my missing thing, my variable that I'm looking for is in the top of the equation. And in this case, that's going to be the right side, right? I'm looking for side C. I want to use that equation, fill in what I know, and solve. So let's do that. I'm just going to move this over here to make things a little more neat and orderly. Side A is 90, and angle A is 65. So we would have 90 over the sine of 65 equals, I'm looking for side C, and angle C is 53. So over the sine of 53. Common mistake here is to not put the sine and just put the numbers, like just put 53. It has to be the sine of 53. That's really important. Otherwise, you're going to get an answer that's not even close to correct. So again, solving, same idea. We're looking for this variable C. To get that by itself, I always want to multiply by what's underneath. Okay, we have C divided by the sine of 53. To get C by itself, we want to multiply by the sine of 53. And I'm just going to put that over 1. That helps some of our thinking, I think. Sine of 53 over 1. And now, one thing that some people like to do is when we get to this point, some people like to put this like sine of 53 in your calculator because it's just a number, right? The sine of 53 is a number. And if you put that into your calculator, you get 0.799. Personally, I like to just leave it like this, carry everything over, and then just punch it into my calculator all at once. So let me show you what that might look like. I might be a little crunched here, but on the left side now I've got 90 times the sine of 53 over the sine of 65 equals C. So now what I would do, instead of finding all of those numbers and then doing the math kind of twice, I can just put all of this into my calculator. So in my calculator, I'm punching in 90 times the sine of 53. Okay, make sure you close off your parentheses on that sine of 53. And then divided by the sine of 65. And when you hit enter, you should get 79.3. You should get C is equal to 79.3 feet. And if you didn't, I would check that your calculator's in degree mode, that you've closed off your parentheses, and kind of look at that if you didn't get 79.3. This is a side, right? We found C. We don't need to do any of that inverse, right? We only need to do the inverse of, like we did above when we're looking for an angle, right? We had the sine of B equals something, and we wanted just B.